Imagine a universe teeming with life, where multiple planets orbit their stars in perfect harmony, each with the potential to host alien civilization. What if, in our search for these habitable worlds, we stumbled upon not just one, but several Earth-like planets orbiting a single star? Welcome back to AstroScience, where we explore the mysteries of the cosmos and ponder the big what-if questions of space. Today, we're diving into the fascinating world of exoplanets and the potential for life beyond Earth. Buckle up, because we're about to embark on an incredible journey to the Gliese 667 star system, where several Earth-like worlds may be hiding in the habitable zone of a distant star. What if we could find multiple habitable planets in a single star system? Let's find out. Approximately 30 years ago, we had no scientific evidence of planets beyond our solar system. Today, thanks to technological advancements and scientific research, we've identified over 5,300 exoplanets, or alien worlds, waiting to be explored. Initially, most discoveries were of large gas giants, but as our capabilities have grown, we've begun finding smaller, Earth-like exoplanets. Scientists have already discovered a significant number of these. There are 50 exoplanets with masses similar to Earth's, and over 800 worlds with radii less than 1.5 times that of Earth. While we haven't found many of these planets in the habitable zone of their parent stars, where conditions might support life, that's beginning to change. As we continue our search for habitable planets, we're starting to find entire planetary systems with multiple potentially habitable worlds, including at least one such system close to our cosmic neighborhood. The Milky Way galaxy contains numerous compact systems around stars similar to our Sun. However, planets orbiting close to these stars tend to be too hot to support life. In contrast, around colder, dimmer stars, the habitable zone is much closer. One example is Gliese 667, triple star system in the constellation Scorpius, about 23 light-years from Earth. It's the first known system where a low-mass star has multiple potentially habitable rocky planets within its Goldilocks zone. Like Alpha Centauri, this system has 3 stars. GJ 667a, the largest star in the system, is a K-type main sequence star with a mass of 73%, a radius of 76%, and a luminosity of only about 12% that of the Sun. At an average distance of 12.5 AU is its companion GJ 667b, another K-type orange-red dwarf, about 69% the mass of the Sun, radiating just about 5% of the Sun's visual luminosity. The most interesting star is the third one, Gliese 667c, an M-type red dwarf with a mass and radius only about a third of the Sun's. It's a dim and relatively cold star, with a surface temperature of 3,775 Kelvin. Despite its small size, GJ 667c has a surprisingly rich planetary system. Initially, scientists believed there were only 3 exoplanets orbiting Gliese 6667c. Further analysis revealed there might be 6, with 3 or 4 potentially habitable super-Earths. A super-Earth is a planet larger than Earth, but not as large as gas giants like Jupiter and Saturn. These planets can be rocky or a mix of rock and ice, and they might have atmospheres capable of supporting different life forms. The closest planet to the star, Gliese 667cb, is a scorching world with temperatures around 200 degrees Celsius. It's the most massive planet in the system, about 5.5 times the mass of Earth, likely with a very thick atmosphere, and it completes an orbit around its host star in just 7 days. The 3 potentially habitable planets in the Gliese 667 system are further from their star and have masses between 1 and 5 times that of Earth, making them promising candidates for habitability. Gliese 667cc, the next closest planet, orbits on the inner edge of the star's habitable zone. It has a mass about 3.8 times and a radius 1.8 times that of Earth, with an orbital period of just 28 Earth days. With an Earth similarity index of 0.85, it's considered the holy grail of extrasolar planets. GJ 667cc orbits its parent star 8 times closer, at approximately 0.12 AU, completing an orbit every 28 days. Gliese 667cc receives about 10% less light than Earth does from the Sun, but since most of its light is infrared, it receives roughly the same amount of energy as Earth, which could help retain water on its surface and create a climate similar to Earth's. However, because scientists aren't certain if the planet has an atmosphere or how thick it might be, predicting the exact surface temperature on Gliese 667cc is challenging. If the planet has an Earth-like atmosphere, heat would be distributed evenly across the planet, resulting in a pleasant 30 degrees Celsius on the night side. Life on such a planet would be very different. Despite this distance, the two other stars would still appear as a pair of bright stars during the day, shining as brightly as the full moon at night. Meanwhile, our Sun would appear as a distant star. Unfortunately, the nearby red dwarf is known to emit intense flares and bursts of radiation, to 1,000 times stronger than those on our Sun. This could pose problems for any potential life on Gliese 667cc, as the planet is located close to its flaring host star. The red dwarf's strong magnetism may also cause star spots, which can reduce the star's energy output by up to 40% for months. Combined with the lack of ultraviolet light emissions, this presents additional challenges for life as we know it. Living on Gliese 6667cc would be unlike anything we're used to, especially due to its high mass. Since the planet is rocky, the gravitational acceleration would be up to 60% higher than on Earth, meaning a person weighing 75 kilograms on Earth would weigh about 120 kilograms on Gliese 667cc. Additionally, a higher mass allows for a thicker atmosphere, leading to higher surface pressure. If the planet has an atmosphere similar to Earth's, the pressure would be a few times higher. Despite being in a habitable zone, Gliese 6667cc may not have conditions similar to Earth's. Life on this planet would need to adapt to fluctuating and low light levels, potentially high atmospheric pressure and frequent flares. However, this doesn't mean life is impossible. We've seen remarkable adaptability in Earth's life forms. The two other potentially habitable planets, Gliese 667ce and Gliese 667cf, further from their star, meaning they receive less energy and could be too cold to support life as we know it. However, a thick atmosphere could help trap heat and maintain favorable conditions for life on these planets. Finding 3 such worlds in the habitable zone of a single system is rare, and finding 4 is almost unthinkable. According to one study, 5 planets in the Gliese 667c system receive solar radiation ranging from 20% to 200% of what Earth gets from the Sun, making them all potential candidates for habitability. However, there are other factors to consider. Any planet within these distances from star C could potentially sustain life due to the right conditions for liquid water. If a planet is too close to its star, water would evaporate and escape, making it uninhabitable due to the greenhouse effect of water vapor, which traps heat and raises temperatures to intolerable levels. On the other hand, if a planet is too far from its star, like the outermost Gliese 667g, it risks being covered in ice. While gases like CO2 can warm the planet and prevent this, too much CO2 can actually cool the planet by reflecting light away. The discovery of densely packed planetary systems around M-dwarf stars, such as Gliese 667c, suggests the existence of many planetary systems with multiple potentially habitable planets. Since M-dwarfs make up over 70% of all stars in our cosmic neighborhood, the number of such promising planetary systems in our galaxy is likely much higher than previously thought. Instead of looking for a single, potentially habitable planet among 10 stars, scientists can now focus on finding multiple Earth-like candidates around one star. And that's a wrap on today's journey through the cosmos. The Gliese 667 system shows us just how diverse and amazing our universe truly is. With so many potentially habitable planets out there, who knows what incredible discoveries await us in the future. If you enjoyed this video and want to stay up to date on the latest cosmic discoveries, make sure to hit that subscribe button and click the notification bell. Don't forget to leave a comment below on which star system you'd like us to explore next. And if you loved this video, give it a thumbs up and hit the super thanks button to support the channel. Thanks for watching AstroScience, and until next time, keep looking up at the stars and asking, what if?